Hello, boys and girls. Thank you for checking in on this electricity parallel circuit video lesson. We learned earlier in class that with a series circuit, the power source generates the flow of electrons or the current of electrons. Um, the conductor, of course, carries that load, that electrical energy, through the conductor and on the path. The electron flow uh, is met by resistors. The resistors resist that electron flow, and then as a result of pushing back that electricity, they're really, the bulbs are using the electricity to actually create light. So electrical energy is being created into light energy. And then, the load, which is in the conductor, travels through the path and it repeats. Now in a series circuit, if we took out one of the resistors, whether it's this one or even this one, or even if we just took out one, what would happen is, well, do you know what would happen? You may have seen this in class and tested it out actually, but the electricity would stop flowing. You would not have any more flow of electricity. So your electricity would flow in the path here, and if one of the resistors was taken out, electricity could not get to the other resistors. Let's try this now. What if we let the electricity flow from the power source through one resistor and we took out the middle resistor? What would happen? Would this bulb still light up? Would this bulb go out, or will it still be lit up? Well, you may have seen that if you did or had something like this, and if you took out the middle resistor, like unscrewed that bulb or broke that bulb, what happens is the electricity in this entire path will no longer be able to flow, and you'll have no electricity. Take a look at a parallel circuit. I want to ask you that same question. If we took out this bulb by unscrewing it from its socket or eliminating it, would the electrical energy, the load, still be able to be carried through the path? Let's try something here. What do you think? Well, if the energy or the electrons are flowing in a path from this power source and they're going this way, I'm going to use a different color, and they're going this way, and I guess they could go this way, right, if they wanted, or they could keep going this way. Now if they reach this resistor where there's no resistance and the path gets cut off, would this bulb and this bulb go out, or would they stay lit? One could argue that this current from the power source and the load that it carries, the energy that it carries, would still continue this way to light the bulb, even if this one is out, and that the electrical energy or the electrons, the current on the path, carrying the load of energy, this would circle back this way and come around. It would not go this way, and even if it tried, okay, but it would go this way to this, and you would have this repeated. So in a parallel circuit, you're not going to have your bulbs go out, all of them, if just one does. Take a look here. Do you think, boys and girls, you could make this in class? You have already made this. Do you think you could make this? And it's called a parallel circuit. Do you notice what's parallel or across from one another? It looks like the resistors are across from one another. Look at this image here. This is really neat. See, this symbol represents the light bulb resistor, and we're studying that resistors, they use electricity to work. The resistor resists the electricity and it uses it to create the light energy. A resistor could also be used to make a sound or to make a fan work, maybe blow something. Convert electrical energy to light energy. Take a look at this path here. Here's your power source. And the path flows this way. And it could go this way, or it could go this way. See, with parallel circuits, your current could take more than one path. If you look at a series circuit here, in a series circuit from the power source, the current only can go in one path, and I'm showing you what that path is right now. And if you get rid of one of the bulbs, the current stops and nothing else could be lit up. But in a parallel circuit, you're flowing your current this way, and it's going this way. And if, let's say, this one gets cut off, or this bulb breaks, or this resistor is damaged, instead of going this way, the electricity will just find its way and go to this. And it will light this bulb, it'll go back around. It'll avoid going this way, and it will just go back around like this, and everything that needs to get lit up will get lit up. Finally, I really like these last two drawings that I want to show you. This is a series circuit. Christmas lights are set up like this. If one of your Christmas lights goes off or breaks, all of them most likely will not light then, because there's only one path for the electricity to flow. In a parallel circuit, however, most of our wiring in our homes is set up in a parallel circuit, so that, let's say, if this was a wire to your TV in the walls and things, behind the walls there's wires or things where electricity flows to, the TV through the socket. If your TV's resistor went off, you would still be able to light up your lamp. Or if your DVD player's resistor broke, you would still be able to operate the dishwasher. I really like this picture. It's the last thing I'm going to show you before the lesson ends. It's called Influencing the Flow Rate on a Tollway. These are cars on a highway, you can imagine. But what's really neat is they also represent a resistance and the flow of electricity. This is using a single resistor, this image here. What you see here then is the electricity or the electrons flowing in one path, and it's very narrow. And this is why your bulbs really didn't light up a lot. There was a lot of load, a lot was being carried, a lot of energy was being carried from one power source through one path, really, that series path. And you can see a lot of cars get clogged up right over here. So a lot of that load gets clogged up. Here we've got 3 resistors and, one power source. And these 3 resistors placed in a series, you can see how crowded it gets. There's quite a bit of load over here. But look what happens when you place them in a parallel circuit. In a parallel circuit, your electricity can flow this way, it can flow this way, or it can flow this way. A parallel circuit, your electricity has a lot of options to get to the resistors. Okay, that's it for now. Take the survey. We'll build parallel circuits in class, and you can sit with me if you want, or you can work in a group and teach yourself how to build them. Thanks. Bye.